All right, let's look at our next optimization problem. What is the minimum vertical distance between the parabolas y equals x minus x squared and y equals x squared plus 1? So first and foremost, I need to just make a little sense of what I've got here. I have two parabolas, they're graphed in my picture. Which one's which? So I have this parabola here, and that one is going to be the y equals x squared plus 1. How do I know? Well, because the x squared is positive, so it's going to open up. And the plus 1 tells me that it's just moved up 1 from the 0, 0 vertex. Whereas this blue parabola here is my y equals x minus x squared. And I can tell that mostly from the fact that the x squared is negative, so that would mean my parabola is opening down. Okay, so I've made sense of which one is which, and then now I need to figure out what they're asking me. Minimum vertical distance. A vertical distance means straight up and down. So I'm not talking about a distance diagonally or with any angle. I'm talking strictly about the vertical distance, which, okay, that wasn't the straightest line in the world, but that's what I'm looking for. This is my vertical distance. Okay. And knowing that, how would you write an equation for that? How are you going to find the d value? Well, this is my x-axis right here. If I start on my x-axis and I go up to the red parabola, what can I call that distance? Isn't it equal to x squared plus 1? And if I start at the x-axis, x-axis, and go up to the blue parabola, isn't that x minus x squared for any given x? So if this was my x value, of course, maybe I'm going to move that x over just a little bit so you can see better. I'm not going over my d. Let's say this is my x. Here's the red distance to the red parabola. Here's the blue distance to the blue parabola. How am I going to find the distance that I've labeled d? I'm going to subtract. So it's the distance to the top parabola minus the distance to the bottom parabola. I guess I could put parentheses here just to make that clearer. And that's the vertical distance. It's a change in y. I could clean that up just a little bit. X squared minus x squared, that'll be 2x squared minus x plus 1. And now I have the vertical distance between these two parabolas written as a function of x. So I will take the derivative, set it equal to 0. Whoopsies. That doesn't look much like an equal sign, does it? Solve. And then I'm going to double check. Now, do I have endpoints for my x? Does my x have a natural smallest value and lowest value? In this case, it doesn't, right? I mean, the x can be any number you want. Certainly, as I get over here, that distance is going to get very large. Same with over here, very large. So I'm suspecting, right, that minimum distance is somewhere in here. Right now, I have a candidate. So I don't even have endpoints that I would need to think about testing. So plug in something less than that, like 0. That would be negative. Something bigger like 5, that would be positive. So this d function has a minimum at x equals 1/4. And if I just peek at the question actually asks me, what is the minimum vertical distance? So the x is where it happens, but the distance, the distance itself, I would need to plug that 1/4 in to figure out what the minimum distance was. And when you do that, you should end up with 7/8.